Hello everyone, today we will see lecture number 16 from Design and Analysis of an Algorithm. Today's topic is Selection Sort Analysis. So this is the algorithm as you can see for the selection sort, where we can take any unsorted list and we would like to sort the list. This is an algorithm for selection sort. Now we will see how we can solve this. Okay. Say this is an example which I took. What actually we do in the selection sort is we have a list of elements. We take the first element, that is the element at the 0th index of an array, into consideration, and then the rest of the elements, in the rest of the elements we have to find the smallest element. If you will see, the smallest element of all these is 13. Okay, so we will take 13, the smallest element, and we will check the condition. If this element, which is the smallest, is smaller than the element at the 0th index, then we will swap it. In this case, this is smaller than this, so we swap the two elements. 13 would be here and 75 would be at its place, and rest of the elements would remain same. Now the thing is, when we take the first element into consideration and find the smallest element, how many comparisons we have to perform, or how many elements we have to search in order to find the smallest element? We have to compare n-1 elements. We have to search n-1 elements in the list so that we can find the smallest element. We have to check if there is any element which is smaller than in any of the elements. Then this is the element at the first index of the array. We have to take this into consideration and have to check the smallest element from rest of the array, which is 24. So swap these two elements and rest of the elements would remain as it is. So after two iterations, are two elements at its correct position. Now take this element into consideration and find which element is smallest among these. 35 is, so swap these two elements. So this will be 13, 24, 35, 42 over here, 75, 87, 64 and 57. So these three are sorted. Now consider this element 15. So this is 13, 24, 35. The smallest element is 42, swap the two. 42, 75, 87, 64, 57. So we have to continue this process till the whole list will get sorted. Take this into consideration. The smallest element is 57, so 57 would be here, 87 would be here, 75 and 64 would be over here. 13, 24, 35, 42, 57. Take 75 into consideration. This is the smallest element. Swap the two elements. 87. Now this list is sorted. Now this is what you have to take into consideration. But you can see this is the element which is already at its correct position, the smallest element. So it would remain as it is. Then at the last we consider this and there is no element left. So we take the list. So bound checking would happen over there. So this is the sorted list which we will get after applying the selection sort algorithm. This is the data structure, how we can sort this particular list of elements using the algorithm, using the procedure of selection sort. Now over here we have to check its analysis. That is the major focus of it. As you saw in pass 1, it will compare n-1 elements. Then in pass 2, it will compare n-2 times. Then n-3, then n-4, then n-5, and so on. So the function for the comparisons, so the function for comparisons will be like initially how many comparisons it has to do, n-1, then n-2, then n-3, depends on how many elements we are having. At one point it has to only perform 3 elements, then 2 elements, then 1 element. This is nothing but the arithmetic series in decreasing order, isn't it? So we will apply the formula. You all know that the summation formula is n divided by 2. This is your discrete mathematics, plus n minus 1 into 2 in the decreasing order, where this n is the total number of elements in the series or in the list. Okay, A is the first element of the list. List in the sense means this function, this. D is the difference between second element and the first element So let us put all the values from the function in this formula. So f of n is equal to, what is n? N minus 1 divided by 2. So 2 times a. What is a? That is the first element, that is n minus 1 plus n minus 1. Okay. D is the difference between the second and the first element. N minus 1 because over here n is the total number of elements in the list, so we substituted n के बदले n minus 1 और इसका अपना minus 1. Okay, so this will be like this. Then into में is g, that is second element or first element की difference, so it will be like this. So this will be n minus 1 divided by 2. This will be 2n minus 2 plus n minus 1 minus 1 into n minus 2 minus n plus 1. So we have to simplify this. N minus 1 divided by 2 is 2n minus 2 plus n minus 2. This will get cancelled out, so this will be minus 1. So n minus 1 divided by 2, this is 2n minus 2 plus n minus 2. Okay, if we will see, if we will multiply this, this will be minus n and plus 2, and this 2 and this 2 will get cancelled out. So this will be n minus 1 divided by 2. You can check it over here. N minus 1 divided by 2. As we cancel 2, there is 2n minus n, that will be n. So this will be n into n minus 1 whole divided by 2. So this is the simplification of this, which is basically equal to n square minus n divided by 2. As I already told you, whenever we talk about complexities, we don't talk about constants. Leave it. And amongst these two, the dominating term is n square. So we can say the worst case time complexity of insertion sort is big O of n square. Its best case would be n, because you have to compare it if the element is still you have to compare it, and its average case is again big O of n square. Mostly we talk only about worst case time complexities, because that is how we can actually compute our efficiency classes. Thank you so much and have a nice day.